Hello everyone, and welcome to another video for AP Computer Science. This video is going to focus on variable assignment, which is giving values to variables, which is a big step forward, and literal values and default data types for those literal values. So we'll see in a moment what I mean by literal values. We're going to make a new class. Last time we were working on the file called data types. We're going to make a new class in the same package, basics. I'm going to right click and say new Java class. I'm going to name this class variable, actually let's go ahead and call it assignment and literals. Because those are the two focused topics that we're going to be dealing with. And so to start, again, I'm going to go ahead and erase my comments. And let's go ahead and begin. As always, we are writing all of our code so far inside of the main function, so we do need to remember that and go ahead and write it out. Public static void main parentheses string bracket args, and then open and close curly braces. So now what we're going to do is we're going to make some variables of the different types that we saw, and then we're going to put a literal values into it. When I say literal, I mean that when we type them out directly into our code. And so we can type in literal numbers, literal characters, literal strings, and literal doubles, so integer numbers and double numbers, and Boolean literals as well. So basically every type that we saw last time we can make literal values of. So let's start off with int, because it is the most common. I'll put some notes because what happens is literal values also have data types. And it may seem kind of strange, but the computer at all times must know if there is some form of data what type it is. It cannot be unknown to the compiler because otherwise it would not be able to validate you're not breaking any particular syntax rules. And we'll see assignment has some very specific rules about what you're allowed to assign where. So we'll go ahead and right off the bat say the definition of assignment. So assignment, the storing of a value into a variable. In other words, the mapping of some value to a location in RAM and the association of a label to that RAM location. Right? So that's the more formal definition. And so what we say is we're storing a value in a variable. What's actually happening is the compiler was told to make some space in RAM, and it was told to associate a particular label with that location. And then we said, can you remember this particular value in this particular location? But we don't ever know where the location is. We instead just know the label. Say, hey, put it in variable x. And then x points to somewhere in RAM. And we don't have control over that. And we don't really want it because it's very technical and it would be painful to have to manage all of it efficiently and intelligently. So instead, the computer thankfully does most of the heavy lifting for us. So let's go ahead and make an integer variable. And remember, the asking for the space is a declaration. So let's declare an integer variable. So we can say int, and I'm going to go ahead and call it num, and then semicolon. So we've declared, and I'll just go ahead and put a note. We've made a declaration of a variable. And now the assignment. The assignment is, the operator for assignment is the equal sign. So we're going to say num is equal to, and I'll go ahead and say 10. So assignment, right? So it uses the equal symbol. That equal symbol is the assignment operator. So it has an action, and the action is to remember that number. So we've just assigned the number 10 to the variable num. So if at any point below line 13 we look at the variable num, we are essentially looking at the number 10. And that gives us a lot of control, a lot of power. So let's go ahead and make another variable of type int. So we'll say int bigger num, and we'll go ahead and say the bigger num is equal to some large number. And there it is, right? And notice we don't put commas. And what I've done is kind of instinctually written it, but again, I haven't been explicit. These are int literals, or they're number literals, and then we have to ask ourselves what data type are they? And I mentioned that literals also have data types. So let's go ahead and put some notes above this. I'm going to go ahead and say integer literals contain only digits and cannot have a decimal point in them, right? So integer literals are only integer literals if they contain only digits and they do not contain a decimal point. As soon as I put a decimal point, they are no longer integer literals. They will be some floating point literal, and then we must establish the data type from there. And so we'll also say, oops, didn't want to do that. We'll also say the default data type for integer literals is int. So when I see this, that 10 is an int. Num is a variable that can hold ints. So now we have to talk about, well, if I have an integer literal, an int in particular, and I want to put it in a variable, the type of the value must match the type of the variable. And if it does not, then it will either cause a problem, or if we're lucky, something will happen behind the scenes to make it work. In this case, there is no conflict. A literal literal integer value with no decimal points is an int by default. The variable is int, they match up, and the assignment is allowed to happen. So let's go ahead and make a proof that this is not effective. If I go ahead and say num is equal to 10.0, immediately we get an error, and if we read the error, it says incompatible types, possible lossy conversion from double to int. And so I haven't written it yet, but essentially it's saying this literal is of type double, the variable num is of type int. I cannot put a double into an int variable. It's like having a box that has a certain size, and you can put certain elements in the box as long as they fit in that box. But once it's bigger than the box, you can't stick it in there. It would not work. So the same idea applies here. So I'm going to go ahead and comment this line out, and I'm going to write a note next to it saying cannot place a double into an int variable. Right? So the error is because we cannot put a double into an int. And now let's go ahead and so the same thing applies here. Notice that this is a integer value. There's no problem. Now if I made this bigger, let's add a couple zeros. Suddenly there's another error. You might say, well, why is there an error? There are no decimal points. This just looks like an int. And in fact, it tells us integer number is too large. Remember the range for integers, or ints. From negative 2,147,000,000 and change to positive 2,147,000,000 and change. And so if we're over 2 billion or below negative 2 billion, that is not a integer literal that can be represented by the default type. And so we have to put something to make that work or not allow it. So for now, we're just going to say we can't do it. Anything over 2 billion and a little bit more will not work. So let's go ahead and try. I didn't mean to get rid of it. So I'll get rid of some of those. So that's big enough. And if we ask ourselves what value is this, there's 100, there's 100,000, there's 100 million. So this is 834,713,000 as a value. And so that fits. That's 1.8 billion. That definitely fits inside of an int value. And if I put a negative, it would also work. And so let's go ahead and do that. And let's say num is equal to oh, sorry, let me do that. We'll do one more thing. So let's do negative num. And we'll say negative num is equal to negative 13,417. So something to note, negative numbers can also be literal values. So integer literals can also be negative. And again, this may seem obvious, but I want to point out that the language itself recognizes the negative symbol, or the minus, which you might call this a minus, which is, remember, hopefully we know that a negative number is essentially 0 minus some number, which gives us a negative value. But in Java, we would call this a unary operator. It only has one input, and the input is a number, and the result is a negative value. And so integer literals can be negative, and as long as they don't have a decimal point, they're considered still int, unless they are out of range of int. And now, the last thing I'll do, before I move on to another type, is what's called reassignment. An assignment is a setting of a value, and reassignment is actually just an assignment. So I can say num is equal to 3. And what we have to recognize is that one of the dangers of reassignment is that the data that was stored in the variable beforehand is thrown away. Again, if this variable is a box, and we put a value in the box, anytime someone says, hey, what's in the box? You look at it and you can see what's inside of that. There's the number 10. And then one day someone says, you know what? I want to put a 3 in the box instead. Instead of taking that 10 and placing it somewhere safely, the 10 is just thrown out the window. And the 3 is stuck in the box, and that 10 is gone. If someone did not take it and store it somewhere else, did not use it in some fashion, did not print it out, the number is gone for good. And so we'll say reassignment is the assigning of a variable that already contains a value. And actually, what I should do is I should take this line and put it And then we'll say, we'll go ahead and say that previous values are lost during. Right, so reassignments are assignments, but they also wipe out whatever may have been there. And that's a potentially dangerous thing, so we are responsible when we reuse variables. Right? If you're comfortable with losing the data, that's okay. If you're not, then perhaps you should make a new variable. So I'll also mention, if it's not clear, that if I ask you on line 19, what value does num have, the answer is 10. Because from line 15, where it was assigned a value, it continues to be 10, and if it's referenced, which it wasn't really referenced anywhere, but if it were, it would still have the value until line 23, and then it is the number 3, and the 10 is gone. And then after line 23, until another reassignment occurs, it has the value 3. And so reassignment is great. It lets us reuse variables, but at the risk of losing data. We must be prepared to handle that in some fashion. Accept it and let it go, or put the number somewhere else. So reassignment can be useful, so I don't have to write too many variables if I just reassign them. Okay, so I think that's good. I could do short and I could do byte and long. They're basically the same. The only thing I'll point out, and this is just kind of as a note, a reasonable thought might be, well, why can I not do this? Let's go ahead and make a byte. And let's say byte is equal to 37. I hope you would agree that if you remember, byte is 2 to the 8 bits. It's 8 bits, which is 2 to the 8, which is 256 unique values. We then said that we cut it in half because we want negatives. So it goes from negative 128 to positive 127, including 0. So 37 is well within that range. And yet an error pops up. Let's read the error. It says, oh, that's of course my mistake. I realize that it's a silly mistake. This shouldn't have happened. I'm going to go ahead and give it a name. Let's give the variable name. So let's call it small. And there's no problem. But we have to recognize that something is happening behind the scenes. And this is going to happen more and more as we do things. And essentially what is occurring is that 37 is an int. But because 37 also fits in, so again, it's an int because the default behavior is if it's a whole number and it doesn't have a decimal point, then it is int by default. But because this int is in the range of byte, it can convert behind the scenes. Again, we're not doing it, and remember it as a byte. So the opposite is not necessarily true. If I say int other is equal to 37, again, I think a reasonable argument might be, well, the number 37 is so small and in range of byte, it should be of type byte. And then a byte can fit into an int because it's less bits and therefore it's converted. That's not really true. The data type is always int despite what range it might fit into. If it's in a smaller range, that's lovely, but it doesn't change anything. This is the one where a conversion happens behind the scenes. So I'm going to write a note. Conversion from int to byte happens implicitly. It means that we're not doing it ourselves. It's behind the scenes. And we'll see this in a lot of scenarios, for better or for worse. Right? It may seem like a bad thing just because, like, why would the computer do something without our permission? But again, this is one of those things where it's confident that no data will be lost. And if no data will be lost, then there's not a problem doing that conversion. So let's go ahead and try some other types. Let's do our floating point types. And again, I'm not going to work on float. I'm just going to work with double. And so let's go ahead and say double decimal is our declaration. And let's say decimal is equal to 10.75. And it works. So let's go ahead and put some notes. And we'll say floating point literals contain only digits and a single decimal point, right? And so if a number has digits and a decimal point somewhere, it is considered a floating point literal. And we will say the default data type for floating point literals, what am I doing? Floating point literals is double. And again, I mentioned that float, even though it exists and is a smaller scale, is not really used. Even Java, the language, says literals are double by default. They want as much accuracy as possible to begin with. And so 10.75 is of type double, and therefore fits within a double variable. The types match, there is no problem, right? So now let's go ahead and try some other things. We can also write decimals as negative. So let's go ahead and try now. We'll say decimal is equal to negative 0.047. Also a double, no problem. Something else that the language allows us to do to be flexible, if you've ever seen a calculator express very small or very large numbers, it typically doesn't show, like if there's 20 different, if it's 20 decimal places, it's not going to show, you know, 0.00, like a bunch of decimal places. It's going to show it in scientific notation, and typically they do not say times 10 to the power, they use the letter E. So you might see something like 1.3 E20. That's the same thing as saying 1.3 times 10 to the 20. And so we can actually express doubles in the same way, in scientific notation. So as an example, we might say decimal is equal to 1.45 E15. So this is the only time that you're allowed to put kind of a loose letter without a symbol next to or connected with numbers, right? And there's no error, E. So double literals maybe as in scientific notation. And I'll also point out that E can also be capitalized. There's no problem whether it's capital or lowercase. And then we can put a negative. That's not saying E minus 13. We're saying 1.14 times 10 to the negative 13. And that's a very small number, right? So so it can be capital or lowercase, it does not matter. And I'm just going to show it and then I'm going to erase it because it's not really helpful. We can also put a plus in front of positives. So for whatever reason, if you feel like saying plus E15, so it's times 10 to the positive 15, you could do that. And in fact, we could do that with positive numbers as well. I could have put positive up here, I could have put positive 37. But just like in regular arithmetic, positive symbols are the assumed default, so there's no reason to put them. Same with our scientific notation, same with our integer or double literals. It's just unnecessary. And so there are different ways of writing scientific notation. And you might be curious as to what it looks like as we write them, and I'll kind of show some examples. I'm going to go ahead and do some prints now. So we'll say system.out.println, and we'll print out the number decimal. Right? So again, we're printing out this variable, and if I run this, so I'm going to right-click and click Run File, we should see this last value because we reassigned, and the last value remembered is the last one, which is 1.14 times 10 to the negative 13. So let's show something else. Let's go ahead and do something like decimal is equal to 0.03. If I run it, then that's what's going to show up, no problem. Now my question is, how many digits can we put until it decides to go to scientific notation, or will it not ever do that? So I'm going to go ahead and put 2 more. And immediately, 4 significant figures. Because remember, this one is not significant because the leading 0, even in front of a decimal, has no impact. So just this is enough. 4 significant figures, and we automatically get scientific notation. And that's not the number itself, that's the print functionality. And later on we'll learn the ability to kind of force it to show a particular way, but I just want to be aware that this is kind of automatic, right? So if I go like this and I put a couple more zeros, it's going to do the same thing. Right, there it is, times 10 to the negative 9. We have kind of no control. And notice when it prints, it capitalizes the E for us. Right? So just kind of be aware of that ability. I believe that's pretty much all we need to know for double literals and double assignment. I think that's pretty much everything. So we'll move on to a next type. We'll go ahead and do Boolean because Boolean is very, very easy. And then we'll do char, which takes a little bit more. We will say a Boolean variable, and we'll go ahead and use that example of is raining like last time. So there's my declaration. And let's go ahead and say is raining is equal to true. So there are only 2 Boolean literals, and this is what makes them so easy. True or false, that's it. So there it is, true, and then I can do it again. I can say is raining equals false. Those 2 assignments Those are the literal keyword values, lowercase true, lowercase false. You cannot capitalize them. It will not work. If you've ever used another language like Python, I believe they capitalize the word true and false in their language, but that's kind of arbitrary. And so in Java, we do lowercase, and those are the only two literal values. Now, realistically speaking, you're not going to probably fill in variables all the time, Boolean, just with true or false. You're probably going to do some logic, and when we get to the logical operators, you'll see how it doesn't matter whether it's the actual value true or false, as long as the thing we assign evaluates to a true or false answer, and then we're still following the rules, right? So true and false literals are the only ones that fit in Boolean variable data types. So now let's go ahead and do char. I'm going to put a note here. We mentioned chars are single characters, and to be more specific, char values are 16-bit Unicode. So what does it mean to be 16-bit Unicode? Have you ever heard of ASCII or Unicode? Essentially, it's the standard in which we represent characters on a computer system. And so I have a website that I found that has basically the entire Unicode character set, and Unicode is 16 bits. 2 to the 16 is 65,536. That's an enormous number of characters. If we look at the first 128, this is these first right here, they actually have the capital English letters and the lowercase English letters and a couple extra symbols. Pretty much everything that's on the standard American keyboard. And then notice there are some of these like deletes and function keys and an enter key and the new line key, a few other ones that are more. LF is line feed or carriage return and stuff like that, right? Carriage return is CR. And then there's the delete key, the tilde, and a bunch of other ones. So that's the first 128 characters. The next 128, let's get this to scroll down. There we go. Nope, still. Nope, you're not going to switch? Come on, switch. Oh, maybe these. There they are. I don't know why it took so long. That's the second 128 characters, and that has some more exotic symbols. We mentioned this, I think, last time, and so we have some accented characters, umlauts, and things like that. Maybe the actual multiplication cross or cross product symbol, not cross product. Yeah, cross product notation, things like that. And of course, there are more. So essentially what happens is, because we have so many spaces, we can start to fill non-English languages. And you can see as I scroll, there's Latin characters, there's Greek and Coptic symbols, there's Cyrillic, and there's just kind of Armenian, Hebrew, Arabic, I mean, Syriac, there's just so many. I mean, you can go through tons and tons of languages, and that was the whole point, is initially, since a lot of computing happened in the United States and Britain, it was mostly English, but as other countries got involved, international groups said, can we standardize how we express all languages in computers? And Unicode was born, and there's actually 32-bit Unicode and 64-bit Unicode, and it kind of goes on and on. So there's just kind of a never-ending huge supply for language, which is fantastic. And now what I'll say is, if we try to print some of these out on the computer, they might not show up just because our computer needs to be set up to show them, but we do have the ability to store them as values in our Java language, right? So it's pretty interesting what's available. So let's go ahead and make a character variable, and we will assign it a value. So we'll say char. And we'll call it symbol. There's my declaration. Let's go ahead and say symbol. And now, our encased, let me say wrapped, in single quotation marks. Right, so I'm going to put it in parentheses. Single quotation marks. And so when we put a literal, I cannot just say, oh, it's equal to the letter A. And the reason we do that is because if we put just a letter, the language, Java, says, oh, you're looking for the variable A. Oh, it doesn't exist, and it complains. So if I want the character A, I must put it in single quotes. And so that's as easy as that. So that's a pretty easy one to do. And I'll try some other values. One maybe that's a little bit more odd, and this one is something we will use eventually, is a space. I put my single quotes. If I hit the space bar, there it is. That is a space character. And that's one that's kind of a weird mix. I mean, is it a visual symbol? Not really, but it is on the keyboard, and it's easy, and it's not like it actually just moves the cursor, but it is considered a space. And Java's capable of understanding it. The backspace might not work out so great. The enter key, not so much, and a few other ones will also need a special consideration. Another thing to point out, capital letters are distinct from lowercase letters. And we kind of saw that in our looking at the Unicode table, how they were separate. So I'm going to stop the video here. We'll continue next time. We'll look at some special characters for chars that need to be dealt with, and then we'll finish up with strings, and then we'll move on from there. I look forward to seeing you in the next video.